Hi, my name is Kyle, and I'll be talking today about Lonboard, a project for fast geospatial data visualization in Python. And so if we're in Python and we want to have a way to visualize data on a map, let's say we have three goals of having something that's fast, simple, and interactive to use. So first, why did we create Lonboard? Why not use some existing libraries? And so Ipyleaflet is kind of like the historical go-to library for interactive mapping in Python, where it uses the leaflet JavaScript library and connects it to the Jupyter Notebook framework. So here, in order to render 300,000 points, it takes about almost a minute to render. Can we do better? There's this library called Pydeck. And so Pydeck is a Python binding to deckgl. It's been around for maybe 5 years or so, maybe a little bit longer. And it's a little bit faster because the underlying library is GPU accelerated in the browser. However, we can do faster, and so here's Lonboard, where Lonboard is this green bar at the bottom that blends into the horizon, and it's so much faster that it literally can support a lot more data than Pydeck and Ipyleaflet. So Ipyleaflet and Pydeck, that was kind of like the end of the back here. This is as many rows as you could plot in Pydeck before it would just crash, and in Ipyleaflet before it would crash. But here, we can plot more data way faster than existing libraries were able to. And so here in a little GIF this is taking data from a GeoPandas geodata frame, applying a different color to every point, and applying a different radius to every point, and sending all of that data from Python into the browser and rendering it in 2.5 seconds. The key here is that this isn't just like a static plot, because you can also do static plotting in, say, Matplotlib, or Data Shader is another great tool for relatively static plotting. But here, this is interactive, that you can explore the map, you can get a tooltip to understand sort of other attributes that are displayed associated with your features. And you can change aspects of the map even after you've started rendering it. But actually, you can even extend that graph even further, because Lonboard is really only limited by the size of your GPU memory that you have on your machine. So this uses the GPU on your local computer that is driven by the web browser itself. So I've had somebody who had a gaming GPU who was able to render 50 million points on an interactive map and have it be still 60 frames per second, totally fluid. Most people, I get to around 5 million points on this laptop, a recent MacBook Pro, before it starts to get a little bit laggy. But I've been able to render, this was 16 million points on this laptop. That was a little bit laggy, but it was still functional. And so here, this is just copying the previous data set a few times. And it's a little bit laggy once you're zoomed out, because it's rendering all of those data at once. But once you kind of filter into a specific area, it's faster. And so if we question just how is this so fast, we kind of have to understand the three parts of rendering web maps like this in the browser. And so you have to get data into the browser somehow, you have to manage the data in browser memory, and then you have to render it to the screen itself. And so historically, the relatively slow old way to do this is to use GeoJSON to get data into the browser. GeoJSON is great in that it's really easy to use, but it has some drawbacks, that it's very large. It's a large JSON encoded string. It's pretty slow to read and write. There's no partial reads in the GeoJSON format. And then once you load that data into memory, The GeoJSON gets parsed with a JavaScript, just JSON.parse into JavaScript objects that have a lot of memory overhead. And if you want to move data onto a different thread in the browser, so that you could do some sort of parallel pre-processing, then that has a lot of overhead and just getting that data between the main thread and the other thread. And then Leaflet is an amazing library that's very easy to use and is very great for very simple projects. But it's not designed for really large scale data visualization. And so if we look at the faster counterpart to each of these, this uses GeoParquet to move data from Python, the Python environment, into the browser. And so this has really efficient compression. And so with this example data set from that GIF from before, that 3 million point data set was like 700 megabytes in the GeoJSON string encoding, but it was only 40 megabytes in the Parquet file encoding. And so this is really fast to read and write. GeoArrow is how we manage this data in memory, both on the Python side and in the JavaScript side. And so because it's the GeoArrow, if you managed to catch my talk yesterday, it's a binary layout of geospatial vector data. And so instead of storing many tiny JavaScript objects, you store a single array buffer that represents all of the data in a column. And this makes it really easy to share the data freely between the main thread and another thread, and you don't have JavaScript garbage collector overhead. And then this also uses DeckGL, which is a really fast data visualization library that is WebGL and now WebGPU, the latest iteration of GPU access on the web, enabled. And so it's really fast to render a lot of data directly to the GPU. And we can copy this GeoArrow data directly into the GPU memory without having to do much pre-processing at all. And so all of these things happen just like in a tenth of the time of just saving a GeoJSON string from GeoPandas. And so the key is that, like, previously there is text encoding and text serialization and text deserialization in many parts of the process. But here you start with some sort of arrow-like input source. Could be GeoPandas, could be DuckDB Spatial, could be SedonaDB, could be GeoArrow Python, could be Shapely objects. This is designed to fit into existing workflows. And Lonboard manages the conversion under the hood to GeoArrow so that you don't have to think about that. And then this uses the AnyWidget library that is just like a wrapper around making Jupyter widgets, these interactive elements in Jupyter notebooks. And that sends it from, it serializes to GeoParquet for over the network into the browser. And then we use GeoArrow the rest of the way into the GPU. And so because of this, this is really fast because we never go into like a text serialization. But it's designed to be really simple to use. And so it has a high-level API called Viz that you can pass in ideally anything. You should be able to pass in anything that's GeoPandas-like, GeoArrow-like, table-like, DuckDB-like. You should be able to pass in anything that has an arrow export like ability. And so even a GDAL Pyogro object, the GDAL Pyogro object has a way to expose itself as arrow, and so we can automatically check for that. Here, this DuckDB integration, you can pass a SQL string just directly into the layer. We call the string on that connection. We automatically manage the conversion of the data from DuckDB into Lonboard, and we visualize that data. And so here, this is a heat map layer that is visualizing that query. We also have a CLI of just one of the initial things that I wanted like 5 years ago when I was just getting into geospatial was a really quick way to visualize just data on my disk that I didn't really understand or know about that data. And so I don't know if many people use this, but some people probably do. It exists and you can check it out. But a key here is that we care about interactive exploration, and so we don't just want, we want as fast iteration as possible so that you can understand your data as well as possible. This is really designed for exploratory data analysis to understand your data. And so we don't want to go back to Python to have to generate more like a new rendering of the data every time we want to change one aspect of how we visualize the data. And so in this case, we're seeing that we sent the initial data once, and then every time we run one of these cells, we're only updating the new colors for each point on the JavaScript side. And so we don't resend the data. We don't send any of the other attributes of the data. All we do to update this is send the new colors. And so you can set either a single color for all points, as the first row or the first line, 46, is doing, or we have helpers so that essentially you can pass a NumPy array or an arrow array that has a row per row in your initial data set. And so that passes in a different color, or you can pass in a different attribute in a vectorized way that's how we're assigning a different color to every one of these really quickly. We also have some cool niceties like GPU-based data filtering. And so we have data filtering. This is all wrapping amazing DeckGL work that we can change these sliders, and the data is not being updated, or the data is not being sent again from Python to JavaScript. This is only sending over that numeric value that the slider is controlling, and that controls what is actually rendered to screen. There's a bunch of different layer types. So here, this is buildings data from the Overture Maps dataset. There's kind of like origin destination data set. This is the DeckGL arc layer, along with this is the extension for, it's called brushing, so that you see only the stuff around the cursor. All of these examples that I'm showing are examples that are on the website. And so if you search Lonboard, I think now the SEO is better because you used to only get skateboard images. But there's, I think, a link to you can go to just ds.io/Lonboard and get to the documentation website. All of these are reproducible Jupyter notebooks. There's also a movement data layer in DeckGL that has a connector to moving pandas. So if you have some sort of trajectory data, then you can really easily visualize that, even in an animated sense, in Lonboard. There's a bunch of niceties that we get by being inside the Jupyter Notebook environment. So there's a tool called Sidecar that you can set a Jupyter widget to be on the pane of the Jupyter Lab screen. So here, this is the interactive map is just on the right side of the screen, and you can go through your notebook, and it automatically updates that right side of the screen whenever you run your cells. There's also, I haven't used this myself, I just made this tiny demo, but there is a way to create sort of applications that are driven by Python. And so here, this is like this is a website that is running in my web browser that is powered by Python behind the scenes and has different widgets that you can create to control how the data is rendered. I know some people have used that. There's some examples here in the docs as well of this is connecting to GeoParquet. This is just a pretty image. It's not really anything special about Lonboard other than you can render lots of boxes. And here this is showing how the Overture Buildings data set is partitioned with GeoParquet across the globe. Then there's some new things in the latest release that just came out a couple weeks ago. One is deeper integration, or really both of these is deeper integration with MapLibre. And so there's these map controls. So if you look at, I don't know if you can see my cursor, that this kind of full screen control, this navigation control, and this scale control at the bottom, each of those, like the scale as you zoom in, it shows you the approximation of the scale per pixel on the screen. And then here on the right side is if you've ever like imagine you're rendering some image data to the map. That image data by default, DeckGL is covering up any base map elements. And so if you render an image, then you end up losing all of the context that base map gives you, any sort of labels, any sort of boundaries, any sort of borders or roads. And so now in the latest release, you can actually set it up to render the text labels or some parts of the MapLibre vector base map actually on top of the DeckGL layers. And so here, this is this image is rendered by Lonboard, but then the labels are rendered by MapLibre, but you can still get both of those. There's also new DGGS layers. So the H3 layer, A5 layer, geohash layer. There is an H3 example on the website, but not yet a geohash or A5 example. These were just in testing. Make an issue if you'd like to help create some of those examples. And then why the name? It's a little bit of a confusing name, but the idea is that DeckGL is the JavaScript library that we're using. A deck is the part of a skateboard that you ride on. And so what's a geospatial skateboard? A longboard. Yeah. It gets drones. And so some future work. I recently got excited about raster data and raster data rendering. And so we don't currently support, or we support like images like PNGs to render in Lonboard, but not like really deep raster integration. And so ideally, we'll be able to visualize COG and ZAR data in Lonboard and ideally be able to animate that data cube of ZAR data. A long time ago when I was just getting into geospatial, I explored this project to do GPU side filtering and band math. And so potentially we can have something like that. If you're interested in working with us on this or funding us on this, happy to talk. The other thing that Lonboard does is right now it's really fast, but it sends all of the data into the browser. And so if you give it 100 million points, like it's going to fail because it tries to send all of that data into the browser. It's able to do all of these steps faster than before, but it's not smart. It doesn't try to be smart today about filtering and limiting what that data is. And so potentially in the future, we could have a smarter relationship between Python and JavaScript. And so if you gave a massive amount of points, we could kind of cluster it ahead of time and have better communication between Python and JavaScript. These are two projects that I ported from JavaScript implementations into Rust to be used with Python. But if this is not really this is kind of on the back burner now. So if this is interesting to you, come talk to us. And then this is just a little example of, because this uses GeoArrow, it is fastest to integrate with any other GeoArrow based tooling. And so here, this is an example of loading that part, this data set, and from disk to Python into to the browser to visualize is less than 2 seconds. And so this entire process is designed to work cleanly in an ecosystem together. This is kind of old, and actually, I think that link goes to an old version of these slides. So that is a little bit wrong. But I will just do a little quick, can you see this? Let's make that a little bit bigger. And so this is using the speed test data set from the AWS Open Data Registry. This is one of the examples in the documentation where this is the same as before, where we can load this data into here. This is a geodata frame. We're creating this sidecar thing on the right side of the screen. And then we can create this GeoPandas, this from GeoPandas to create the scatter plot layer. The default is that it's just black because you haven't given it information. But then this is where we can make it interactive. If we just set a new attribute and it changes the color into blue. Blue is not very interesting. And so we really want some sort of data-driven styling. and here. So this data-driven styling, we are applying the download speed for each point into a color map. And so here, the browns are places where there's less color, and the greens are places where there's more color. And so here, just setting that NumPy array of colors automatically updated that on the map. And so here we can also this is setting a different radius for every point based on the relative internet speeds. And then we can just kind of zoom around, see what is more or less fast internet speed. And just because this is my favorite demo, I'll try to do this air traffic control demo that that fetches from the network. So hopefully looks like, so here this is a blank map still, but that's because we haven't animated the layer. So here we create this, we play that button. This is data that is coming in and out of the 3 New York City airports. I live in New York City. And you can kind of see the flights going over. This is one day in UTC, so this is, I think, at night where all the flights go over to Europe. Those really fast lines are because I don't do anti-meridian handling correctly. So it's flying from one side of the globe to the other. It could be better, but this is cool. So, and that's it.
There's time for questions. I've got a question. I didn't notice the version number starting with a 1. It started with a 0.0. You reckon this is prod quality, or is this dev quality?
I mean, it's prod quality, but I've actually never had a project that I've taken to 1.0.
Nice.
So I really should sometime, but I'm just always scared because I make occasional breaking changes. But actually, this hasn't really had a breaking change in like a year and a half. So it's probably production ready.
Any questions, please?
Do you have any thoughts about going into Lonboard straight from like Spark data frames, like PySpark?
Part of the simplification here of Lonboard is that because we go through Python, we can do some sort of pre-processing, even if it's fast for the data. I think PySpark might now even advertise it as an Arrow compatible exporter. And so if it does, then you can literally pass the PySpark data frame object into a Lonboard API, and that will just work. Otherwise, you can do the PySpark like to Arrow method and then pass that in. But either way, it's going to go through Python.
Yeah, like Parquet would work, but it's an extra write-out step, and so yeah.
I mean, somehow you have to get the data from Java into Python.
Yeah,
so
yeah.
Okay, thank you. That.
This works with an emulated GPU, like in a Citrix environment or something like that?
It's a good question. In general, DeckGL performance is just not as good with emulated GPUs. So like with any sort of hardware, even if somebody has like an integrated GPU that's a little bit older, like it still works well up to some number of points. I've never tried this with an emulated GPU, or maybe we do in the test now, but I have no idea how well it works. I mean, you might be able to ask Felix. He's a DeckGL developer.
Any other questions? I've got a question. Is this a DevSeed product? Is this like a corporate product? Or is this just something you're really interested in?
It's a DevSeed project, so it's on the DevSeed organization GitHub. DevSeed has funded a lot of this work. But Development Seed, we are a consultancy, and so we have like open source projects to work with scientists, and we have contracts with NASA and European Space Agency and others. And so this is not like a product. I mean, it's an open source project, if that answers your question.
Any other questions?
You have?
Yes, in the back. Last question.
More just an observation rather than a question. I'd just like to say thanks. Yeah, we live for a long time, geospatial person, 30 years or more, just seeing what's happening at the moment with the arrow stuff, and and people like yourself that are taking that and really producing something really useful, and your stuff is getting used. I'd just like to say thank you for that and putting your effort in. Thanks.
Well, thank you. Thank you.